Welcome, Averst. You are the CEO of Rolling Stock at Siemens Mobility. Can you tell us a few introduction about your role?
Yes, of course, Antonio. Will be a pleasure. So my role is within Siemens Mobility to take care about everything that runs on wheels. Starts with the tram and ends with a high-speed train, and any kind of propulsion you can imagine.
You announced this week a partnership with Deutsche Bahn to build an hydrogen train.
Mhm.
What can you tell us about the prototype?
Yes, I think this hydrogen prototype is quite an amazing train we have in the portfolio because since quite some time we think about what can we offer to our customers to replace the conventional diesel trains. And diesel trains served for a long time, I think, into the overall network of our customers, but increasingly our customers tell us it's probably the time to replace diesel trains by something more modern. And at the same time, we cannot electrify the whole network. And we have two options here. We can use batteries and hydrogen. We at Siemens Mobility, we started with a battery train. We have a prototype on test since quite some time. And we have the first order in our books already for battery operated trains. But we clearly felt battery has strong advantages when going shorter distances and probably not too much up the hill. And hydrogen is a source of energy we really should use to serve those kind of applications where our customers want to go a couple of 100 kilometers and up the hill and probably even pretty accelerating fast, which sometimes is really a key issue in large cities where the network capacity is a restriction and you have trains going quickly one after the other. So acceleration and braking is an issue. So then we said this is a technology we want to have in the portfolio, a pretty challenging new technology, and this is why we decided for a prototype. And the prototype started with trying the technology in a lab, but then we said, but now we are fit to really run this on a rail. And then we decided to build the prototype and not only to use it, let's say, for test applications, but together with Deutsche Bahn to really use the prototype in public transportation, in real applications, in order to find out what are in operation the advantages and probably disadvantages as well. And the technology is quite far developed due to the fact we use the standard train. We have the Mireo, I would say one of our flagship products, and we just implement this hydrogen technology combined with the battery in order to serve them in non-electrified networks.
So you partner with Deutsche Bahn and they will install the corresponding infrastructure. Mm-hmm. What will be the setup? And is this a solution that could be rolled out at scale?
For sure, I think yes, that is the plan. We developed this technology pretty far, and we said it's now time to use it in real passenger operation. And we are so glad that we were able to convince Deutsche Bahn to collaborate with us because they operate these trains. And in this application as well, they supply the hydrogen. They generate, and that's important in this application, green hydrogen coming out of solar energy or wind energy. They convert this energy then using electrolyzers into hydrogen, and we fill the hydrogen then by high pressure refueling into the train. Fast fueling, by the way, only 15 minutes for refueling. And these trains then will run in a standard schedule of Deutsche Bahn, making more than 100,000 kilometers in this application. And we expect very good operational results. And this solution altogether then is fit for a rollout to a larger or probably even very, very large scale.
So where do you see the benefits of hydrogen? Also compared with other alternative drive solutions, such as battery-driven trains.
So I think altogether the best way to run a train is under a catenary system using electric energy. In Germany, for example, 60% of the network is electrified, and it's similar in most European countries, but you cannot electrify to 100%. It's not reasonable. If the sequence of trains is low, or probably there are lots of tunnels, bridges, and so on, you need to have a solution for non-electrified networks. And here, I think for short distances, it's the battery. For longer distance, hydrogen. But additionally to this, we live in the world where the whole energy supply changes and we have more and more renewable energy. But on a windy, sunny day, there is surplus as well of electric energy. And to convert this surplus of energy into hydrogen, to me, makes a lot of sense. And then to use it, for example, in trains, brings an overall pretty good balance on behalf of cost and environmental impact. And the technology allows to build pretty powerful trains, where I have to report we always combine the fuel cell with the battery as well. Because for the quick acceleration, we take the energy out of the battery. The fuel cell then reloads the battery. And we have the big advantage when braking the train, you can regenerate the electric energy by buffering it into the battery. And that gives an overall pretty attractive cost of operation. I think for our portfolio, we need both. We have the battery trains and hydrogen trains, and it depends a lot on what the customer has in mind and what the application is. And the complete portfolio from our perspective includes electric trains, battery trains, and hydrogen. And we intend to develop all three elements of this portfolio according to the always most recent technological standards.
So thank you so much, and I look forward to be able to go back to this story again and see any further developments after the announcement.
Thank you very much, and it will be a pleasure to see you as our guests, seeing the prototype and making one of the first rides of the prototype, and hopefully then more normal